Hello students, today we will discuss about the shortest distance between skew lines. This is the most important topic for JEE Mains as well as JEE Advanced. As you can easily expect 1 to 2 question in JEE Mains as well as JEE Advanced. So before talking about JEE Advanced, let me first explain you about the skew lines. So before moving towards skew lines, let me explain you that how many types of different line I can easily draw in 3D. So let me tell you types of line in 3D first. So first type will be I can easily draw two parallel lines in 2D plane as well as in 3D plane. So I can give it name as parallel lines. Second type will be our coincident line. Coincident line is actually the specific type of parallel line only. When the distance between parallel lines becomes 0, it becomes coincident line. So this is our coincident line. And the third type will be our two intersecting lines. I can easily draw two intersecting line. These both lines are intersecting at a common point. And after that there is a specific type which is neither parallel nor intersecting. Now many students face problem here. Actually they are not prepared for this part, like they are thinking that how we can draw such type of line which is neither parallel or nor intersecting. Actually its other name is only skew lines, which we will discuss today. So coming on our part skew lines, so in this box you can easily see that there are two lines are drawn. Let me give name it as L1 and L2. Now if you can definitely see here that these line L1 and L2 will never intersect each other. So I can say that L1 and L2 are the pair of skew lines. So these are the neither parallel nor intersecting line. So the question comes that how you will find the shortest distance between any two skew lines. So first of all, let me take an example. Just let us draw a diagram like in this way. Let me draw one more line here. Yeah. Now we have to find the shortest distance between both these lines, and you all know that shortest distance always lie along the perpendicular path, along the perpendicular line. आप लिख सकते हो यहाँ पे shortest distance lies along perpendicular line. Okay, I think it is clearly understandable for each and everyone. So moving further, we will discuss about here. So first of all, let me draw a line which is perpendicular to both line L1 and L2. So this is our line L1 and this is line our L2. Let me take the equation of line L1 as a vector plus lambda m vector and L2 as b vector plus mu m vector. Here a is the position vector of line L1 and m vector is the parallel vector of line L1 and b vector is the position vector of line L2 and n vector is parallel vector of line L2. Now we will take these points as P and this point as Q. So this PQ distance is the shortest distance between line L1 and L2 which we have to find. So our here main job is to find this small d. Actually this small d representing here the shortest distance. So how we will find this shortest distance? We will use the method of projection here. So we know that a vector is the position vector of any point on line L1. So let me take this point as a vector and naming it as capital A, and let this point is B and this is its position vector is small b. So now we just have to find the projection of this AB on PQ, and that will become equal to shortest distance. So our D will become equals to projection of AB, projection of AB vector on line PQ vector, or we can directly say on PQ vector. And you all know the process of finding projection AB on PQ. We can easily write AB vector dot PQ vector divided by magnitude of PQ. As we all know that the distance can never be negative, so we have to take a extra modulus here. So this will be our main and final formula to calculating the shortest distance between pair of skew lines. So now let me explain this in more detail. Like, can I write that AB vector as B minus A vector? You all know that thing. Dot PQ vector will become like, we all know that PQ is the line which is perpendicular to line L1 as well as line L2. So I can easily write here PQ vector will become equals to M vector cross N vector. So just keep it in mind that PQ vector is the parallel vector to the line which is perpendicular to both line L1 and line L2. So I can write as PQ M vector cross N vector and divided by magnitude of M cross N vector. So this will be our formula for the shortest distance in vector form. But uh, if the conditions are given in scalar form, for example, just if equation of line L1 is given as x minus a1 upon m1 is equals to y minus a2 upon m2 equals to z minus a3 upon m3, and L2 is given as x minus b1 y minus b2 and z minus b3 divided by n1 n2 and n3. Now how I will write this formula in scalar equation? So we can directly use that. It is clearly visible that it is actually written here is STP of vector, actually scalar triple product. We can say it scalar triple product of vector, scalar triple product. So we can write it another way, it like B minus A vector M vector N vector box divided by magnitude of M vector cross N vector, and taking an extra modulus so that our distance should not become negative. So we can easily see here that let me change the font first. Yeah, we will take this one. So you can clearly see that B vector minus A vector will become B1 minus A1 B1 minus A1 I cap plus B2 minus A2 j cap plus B3 minus A3 k cap, and here M vector will become M1 I cap plus M2 j cap plus M3 k cap, and N vector will become like N1 I cap plus N2 j cap plus N3 k cap. So now we have all the data with us, so we can directly apply the formula and proceed for the result. So our shortest distance that is equals to small d will becomes equals to B1 minus A1 B2 minus A2 B3 minus A3 and M1 M2 and M3, and here it will become N1 N2 n3 determinant divided by I cap, j cap, k cap. Here we are taking magnitude of m1 and m vector and n vector. So it will become m1, m2, m3, n1, n2, n3. So this will become our formula for finding the shortest distance between skew line. Let me explain you one more time what we did here. We have just used the concept of projection of AB on PQ. We have directly used AB dot PQ upon magnitude of PQ, and we have finally concluded the formula this one. So let me make a box here and makes, I think, as much as stars as I can make. I have to make that much. So in this formula, on this formula, every year students are getting 1 to 2 question in JEE Mains. Okay, so let us see one question first, then we will see that how our formula will work. So these two line of equations are given L1 and L2, and you have to find the shortest distance between these lines. So first of all, let me exclude the data from these lines. Like here I can clearly see that A vector is -1, -2 and -1 and M vector is here is 3, 1, 2. So here B vector will become like 2, -2, 3 and n vector will become 1, 2, 1, -2, and 3. So it will our A vector, B vector, M vector and N vector. And now I can directly use this formula here, which we have excluded from this result. So let me copy this and we will directly use this formula. So let me directly use this formula. I think this thing is not working. Okay, no worry, we will write it once more time here. So see, now I have to use that formula, so I will use directly the result only. See here, see, we know that now our shortest distance will become equals to A2, yeah, we can say it like B1 minus A1, B2 minus A2, B3 minus A3. Here M1, M2, M3, N1, N2, N3 determinant divided by I cap, J cap, K cap, M1, M2, M3, N1, N2 and N3 and its magnitude. And we are taking one extra magnitude here, or we can say extra modulus here, so that our distance should not become negative. So we will apply direct formula. So D will become B1 minus A1, so 2 minus 1 will become 3, minus 2 will become 0, 3 minus 1 will become 4, and M1, M2, M3, N1, N2, N3 divided by it will become like magnitude of I cap, J cap, K cap 3, 1, 2, 1, -2 and 3 and we are also putting an extra modulus here, so the distance should not become negative. So solving the numerator, I will get 3 plus 4 plus 0 plus 4 into -6 minus 1. So what is the value that finally we are getting here? I think we did some mistake here, students. Let me check. 3, 0, 4. Okay, yeah, everything is fine, don't worry. So we will divide here by magnitude of I cap, J cap, K cap. See, Okay, everything is fine. So I cap, it will become 3 plus 4 minus j cap, and it will become 9 minus 2 plus k cap, it will become minus 6 minus 1, and we'll take one more modulus, and here we will take magnitude. So on the upper part we are getting 4 plus 7 3 are 21, and here we are getting minus 28 divided by, here we are getting 7 I cap, and it will become our minus 7 j cap and minus 7 k cap, and it will become like, let me check, either we did everything is fine or not. Just let me check calculation one more time. It is written here minus 1 minus 2 minus 1, it's fine. 3 1 2, it's fine. 2 minus 2 3, this is also fine. Okay, we did students, we did just a small mistake here, so we can take it as a minus sign. Okay, don't worry. We will just do the calculation in here only. I just putting minus here also. Okay, so our calculation will be all okay. Now it will become here 21 minus 28 will become minus 7, and divided by, here magnitude will become 7 root 3, because it will become 49 plus 49 plus 49 and whole magnitude. So here I will get 7 upon 7 root 3. So 7 will cut from each other, and our final answer will be 1 by root 3. So this will be our shortest distance between line L1 and L2. So in this way we can solve any question based on shortest distance between skew lines. Hope you will understand the topic very well. So in next class we will discuss about the planes in 3D. Okay.